happened, the T statistics for the GDP of Canada was 32, and from 32 it came down to 3 just in one step. Why this happened? Because you have included the relevant variable in the model. But still this is significant, and this is significant because the actual determinant of consumption of Pakistan are still missing. The determinants of consumption of Pakistan are the past consumption and past GDP of the Pakistan same. And let me include these variables, then you will see there is no significance of Canada. Let me see. I am including leg of GDP of Pakistan and leg of consumption of Pakistan in the model, sorry. And then repeating the analysis. The result is again in front of you. Okay. What is the T statistics for GDP of Canada? It's 1.37, insignificant. So without doing the co-integration analysis, I have eliminated the spurious regression. And how I eliminated? I only introduced the relevant variable in the model, and that's it. So whatever model you have, suppose y is your dependent variable. If you include the determinants of y and there is any irrelevant variable, it will automatically wipe out. And this happens most of the times. Yes, if you have lag valued models and you have relevant variables, that's all. That is what you need to avoid spurious regression. Yes? Yes. Okay. If you are having the data for India instead of Canada, you can basically repeat this exercise at home. You will see same kind of results. If you don't have relevant variables, the GDP of India will be significant. But as you keep on including the relevant variable, the GDP for India will become insignificant. Now, one thing was pointed out by Mubin Sahab is that the two series are upward trending and the spurious regression is because of those trends. Now look, we haven't detrended the series. The series are still upward trending, but the spurious regression is eliminated. So this means upward trend was not the basic thing. The basic thing is having relevant variables in the model, and that is what is needed to eliminate the chances of spurious regression. Understand? Now, again, why the conventional wisdom which is so popular is false? They are saying that spurious regression exists because of non-stationarity, and I will show you that this is not the case. The spurious regression can also exist when you have stationary time series. And this is what we have illustrated yesterday. I will repeat the exercise. See, I am going to Excel. here I am generating some stationary time series. Uh, uh, it does not matter how long series you are generating. This is the command through which I have generated the data. These two columns are IID, means independent and identically distributed, which is equivalent to saying that these are white noise. These two columns which I have generated in front of you, these are white noise. Now I am creating two more series. This is, say, epsilon x and epsilon y, and now I am generating stationary series x, which is equal to 0.9 multiplied by x minus 1 plus epsilon x. This is equal to, in first series I can just copy simply, and first number, and from second number in the similar way you have, here is y, it's y, यहाँ से the series is starting. I am writing equal to 0.9 multiplied by the past value plus epsilon x. And if I drag the formula to the right, it is now, look at this formula. This I am standing in D3, and this is equal to 0.9 times D2 plus B3. So these two series which are generated in column C and D, these are also independent of each other, and these are stationary because the coefficient is 0.9. I am making two other series as well. Let me name this as xt equal xt minus 1 plus ext, and then you have yt equal yt minus 1 plus eyt. Yes, sir. Please try to understand this. Try to understand this. We have epsilon x and epsilon y which are independent. Now I am making xt which is equal to xt minus 1 plus epsilon xt, and similarly I am making yt which is equal to t minus 1 plus epsilon yt. I have taken coefficient 1 and 1 here. These two will become unit root. Now, this x is depending on its own value and epsilon x. Y is depending on its own value and epsilon y. And there is no interrelationship of these two. These are independent. Similarly, I am also having two other series which are constructed in this way. Xt is equal to 0.9 xt minus 1 plus epsilon t, and then yt is equal to 0.9 yt minus 1 plus epsilon t. So these two series are also independent of each other, and these are stationary because the root is less than 1. Now I am what is happening? C is independent of D, A is independent of B, and E is independent of F. All of these pairs are independent of each other. Now I am going to calculate regressions for these. First I am running regression for